And now we will really go into the human impact session, and obviously something that is very dear to me and to my job, because being a lead in digital ethics, this is really about sort of how do we create trust in the general public, that we create acceptance for this technology, because without trust in how this works, we cannot really convince the public for this technology, and if the public refuses this technology, we can never introduce it. So this is also a certain responsibility that comes with us as researchers and as developers. Really, okay, how do we explain this? How we make it understandable for people? How we make it auditable? And how would we make people trust this? And you can do this by sort of like we did at Merck, and Professor Beckmann already mentioned, by sort of setting us ethical standards and principles, and sort of defining basics where we adhere to. And we will hear at the end of the session, we will hear a very good overview into really the ethical aspects. But first of all, I would like to welcome Professor Roberto Zicari now. He's an affiliated professor at the Götterstaden Arkada, Helsinki, Finland, and an adjunct professor at the National University of South Korea. And he's leading a team of international experts who defined an assessment process for trustworthy AI called Z-Inspection, and he's going to talk about this today. Previously, he was a professor of database and information systems at Goethe University, and he also founded the Frankfurt Big Data Lab. And he is a recognized expert in database and big data, and with interest in ethics and AI, innovation and entrepreneurship. He's also the editor of obdms.org web portal and the Industry Watch blog. And he was for several years a visiting professor at the Center of Entrepreneurship and Technology with the Department of Industrial Engineering and Operations Research at UC Berkeley, US. So thank you very much for joining us today, Roberto, and we're looking forward to your talk. Just need to okay, so you just need to unmute yourself.
Thank you.
Yes,
John.
okay, now we can hear you. Very good. So let's go.
For the kind invitation, and hello everybody. I'm happy to present in 20 minutes the work we did in 3 years, so that will be an interesting challenge. This is basically our work in assessing how AI is trustworthy in practice. So the question here, if you look at this quote from a kind of famous colleague, is artificial intelligence has the potential of helping, certainly. And here is the catch: as long as we manage to keep this technology beneficial. I put beneficial in italics because really the question is, but how do we know when an AI system is beneficial or not? And our work has been inspired by both theory, practical guidelines developed in the meanwhile, and practices. And we always have to consider, when we look at the implication of an AI system within the context of 4 phases. There's a design phase, early design phase, a development phase, deployment phase, and when the system is deployed, is a monitoring phase. Often the monitoring phase is actually forgotten, so it's important that when one considers the implication of the use of an AI system within an ecosystem, one is really looking at the 4 phases. The first 2 are basically an attempt to, in design, consider some of the ethical implications. The last 2, deployment and monitoring, is to assess the results of something that is being implemented. It is very important, and that's our experience, to include a full community of stakeholders, possibly at all stages of the AI lifecycle, which is not obvious, especially in the current practice. So our work is based on best practices. We started in January 2019, and we basically considered 4 real systems. One was predicting cardiovascular risk. The second was an AI system for helping detecting cardiac arrest in emergency call. I will speak about this as an example. The third one that we did, it, by the way, exactly with the previous speaker and his team, we helped them in the early design of a deep learning-based skin lesion classifier. And now we are currently working on a very large use case of an AI deployed in a hospital in northern Italy for as a deep learning for predicting the lung compromise of COVID patient. And we are looking at the following. So when you assess an AI system, you have to decide on trade-off. That could be, it is appropriate to use. Sometimes it could be that the system is technically feasible, but is not acceptable for other reasons. Or it could be that the system needs some mitigation for reducing risk. Or in some cases, it's not really a good idea to deploy, or if it's already deployed, we should be able to redress. So just to see whether it's possible. Let me give you a real example so you have a feeling of what I'm talking about. So this is a case where we've been working for half year, and it's basically together with the so-called Emergency Medical Dispatch Center of the city of Copenhagen. They are handling the emergency call 112. Of course, you're familiar because then when you call, often there's an ambulance coming. The problem was that the medical doctors of this organization, which is a public organization, it's a government organization, understood that 25% of cases of calls or so-called out of the hospital cardiac arrest were not detected. So now, for some of you, you might not know, there's a difference between a cardiac arrest and a heart attack. In a heart attack, the heart is still kind of working, and so the person is still able to talk. But with cardiac arrest, the electrical signal of the heart is not working, so the person is clinically dead. So suppose that somebody is calling in panic and is actually trying to explain to the person on the other side of the call, so-called dispatcher, that there is an issue. Now, if the person in the conversation is able to understand there is a cardiac arrest, is able to instruct the person to do a so-called cardiopulmonary resuscitation. So you see, this is the bystander, the person is clinically dead, is calling in panic, is receiving from the phone instruction to do a so-called cardiopulmonary resuscitation. You really have only 5 minutes, because if you don't do it within 5 minutes, the brain might be damaged. There's a liability issue, which is very strong, because if something goes wrong, the person answering the phone, the so-called medical dispatcher, are liable. So if they, for example, didn't follow a protocol or anything, they are liable. And they're people's lives, so people might die. So basically, and this is really the interesting situation, so the goodwill, so the medical doctors work together with the startup of the University of Copenhagen, and they together, the technical people and the medical doctor, gave them the audio files, so the data, and they created an AI system that was able to listen to the conversation and predicting if from the conversation there would be a possibility of a out of the hospital cardiac arrest. So the idea was that you call, now your call is actually monitored. That's a bystander, that's a dispatcher, they are calling. But now there is an AI system that is listening to the call, looking at the pattern, transforming the audio file in text, and is alerting the dispatcher, hopefully early enough, so that the dispatcher, if he didn't really catch it, can do the instruction. So interesting enough, they did a retrospective study, so they checked the AI system with all the audio files of 1 year, and it performed quite well. So since they knew which of these cases were really cases of out of the hospital cardiac arrest. So the AI system laboratory was working well. Before deploying, they even did a randomized clinical trial with about 5,000 emergency calls, split it in 2 groups, one group of dispatcher alone talking in real, and one group of dispatcher talking together with the assistant. And the interesting thing that they actually had no significant improvement. Basically, something was not really functioning as they were hoping, because the AI system, although was blinking, the dispatcher didn't pay attention. Nevertheless, the AI system was put into production in fall 2020. By the way, now is actually deployed in all regions in Denmark. And somebody, that's very important, authorized the use of the AI system, although the results were not necessarily positive. They were not even negative. So that's how it looks like. You know, this is the dispatcher calling. That's an helicopter you can send. That's actually the AI system. It's in place. So if you call 112 in Copenhagen, then basically there is an AI listening to your call. So why the dispatcher didn't seem to trust the AI system? And the most important question for us was, is the AI system helping or harming people? So that was the motivation. So we conducted a self-assessment together with the key stakeholders, and we brought in a team of independent experts of various disciplines, from philosophy to public health, medical doctors, engineers. And basically our motivation is to learn and give recommendation. What is the impact of this system? We use a process that we developed in the meanwhile called Z inspection, that looks at ethical, technical, legal, and domain-specific issues. And we use an holistic approach, so rather than a monolithic or static checklist. And it's like an orchestration process. I don't have any time to go into detail. If somebody is interested, I'm happy to follow up on that. So that's basically our process. But I want to give you and our process is actually based on what we call the framework of Trustworthy AI that the European Commission has actually put forward, which contains three parts. It should be lawful, respecting the law, it should be ethical, and it should be technically robust. Now, the Trustworthy AI framework that is put forward by the European Commission, well, actually the independent high-level expert group on artificial intelligence, but is also taken as an input in the new proposed AI regulation, is looking at four ethical principles that are rooted in fundamental rights. The first three, you are not surprised, because respect for human autonomy, prevention of harm, fairness, you find it in bioethics. They invented a new one called explicability, which is even a new term. And there are obviously tension with that. With the four ethical principles, you don't make decisions. So they try to give practical requirements. In particular, they give 7 requirements, and including sub-requirements. The requirements are this one here: human agency and oversight, and includes even fundamental rights, technical robustness, safety, which is more the technical part, privacy and data governance, which is really the part on privacy and quality of data. And here is the interesting thing, you know, the explicability turn into transparency, because sometimes if you have a black box, you can't really explain. And then they have various ways of trying to tackle this area, like traceability, explainability, and at least communication. And then you have diversity, non-discrimination, fairness, whatever that fairness means, because it's really depending on the context. And then something extremely general, society, environmental well-being, and the legal part is accountability. So when we built a team that was really doing the assessment, we learned that the choice of building a team has a very deep ethical implication. Number one, if the team is biased, or if it's actually too homogeneous, or the expertise is only one focus, it would be a very important side effect on the whole result. So what we learned is that we don't only look at the AI system, we look at everything around it, people, processes. So it's really the ecosystem that we have to look at, because the AI system is part of something bigger. And we use what we call socio-technical scenarios, that are ways of bringing different stakeholders with different vocabulary to try to understand the aim of the system, the actor, the expectation, their interaction, the processes where the AI system is used, and the technology. And the idea is that you go from a novel vocabulary where people talk with their own language and go into a consolidation process that map into the Trustworthy AI. very important in this understanding of the implication is to develop an evidence base. An evidence base is really something extremely important because you have claims. The system claims to be better, it claims to be faster, it could be more accurate. And actually, the interesting lesson learned is that when you bring experts, in our case, we're all medical doctors of different kinds, even experts might have different opinion. And so evidence is not an obvious definition. So who is qualified to give a strong evidence and what is evidence is actually quite a challenge. And then you have ethical tension. And some people, if they're not trained, especially us as engineers, we're not trained in ethics, sometimes it's good to give them example of tension so that they might understand what we talk. So for example, you might have a system that's very accurate, but it might not be as fair as you want. And if it's fair, it might not be as accurate as you wish. So that's the tension. Or it could be that the system is very accurate, but you can't explain it because it's a black box. And if you force the explainability, you lose accuracy. So these are examples of tension. Quickly, back to our use case. So one of the major risks that we assess, because it's about risk assessment here, is what happens if the AI system doesn't agree with the dispatcher. Also, why there was no lack of trust. And this is really related to the principle of human agency and oversight. So either the dispatcher didn't pay sufficient attention, or the system might have had too many false positives. Meaning in this case that the system is very accurate, is detecting every kind of out of the hospital cardiac arrest, but sometimes is detecting even cases where there are no cardiac arrest. And that would mean sending an ambulance or asking to do a cardiopulmonary resuscitation to people that don't need it. And lack of explainability was one of the things that was clearly identified because the system was a black box. So the dispatcher and nobody could really understand how the system was actually implemented. And that means communication. Also, very important, we figured out that the system was trained using data of audio files of calls, and the system was trained with people that are good in speaking Danish, which is not an easy language. So whenever there was somebody speaking a dialect or a foreigner trying to speak Danish or even speaking another language, the system might not have been that accurate. And not being that accurate has a major risk of not detecting a cardiac arrest. So maybe then you have the opposite situation where the dispatcher thinks there is a cardiac arrest and the machine doesn't say anything. Then you have an issue because all of a sudden now you have an AI system between the decision. And it has to be done very fast. That's a very good example of a case. We just finished phase 1. Now we will continue next year with phase 2. And we already gave recommendation to the stakeholders how to take care of all of this issue that we actually look at. You can actually look at some of the resources on this website. There's plenty of information. And I was asked to speak in 20 minutes. I think I made it in 19, which I'm kind of happy about it, so that we have more time for questions. Thank you.
Very good. Thank you very much. That's very interesting. And obviously for someone like me who really thinks about the ethics piece a lot in his daily work, it's interesting to see how you can assess this. I mean, we already have a first question coming in. This is from Manuel. He's actually specifically asking about the Copenhagen example. Are the users or the callers and call center also informed about the capabilities and the limitations of the UI solutions in place?
We probably, actually, thank you. If I understood correctly, the question is who knows about the result of our assessment? So
it's more about the sort of where the users informed about the capabilities and the limitations of the AI. So
the user, well, if your user are the people calling 112, certainly not. So that was one of the things we also identified, that if you are a person in a house and you are in panic for all kinds of reasons, and you call 112, there is absolutely no information whatsoever that there is an AI system listening to you. But you have to understand that it's not an easy thing, because if you will start having a recorded voice that says your call is being recorded by an AI system, would you agree on the call and stuff like that, you will lose a lot of time. So that was one of the things that we identified. There is no information being given to various stakeholders that there's an AI system now in between decisions, including the people calling and family.
Okay. And so, I mean, there's more questions on the example coming in. So also Harsha is asking, was there a case where output of the AI confused the dispatcher?
That was one of the big things that we identified. So the AI system is very accurate. So it is very accurate in detecting a case of cardiac arrest, but it has too many false positives. So meaning that sometimes it's blinking or it's signaling when it's not necessary. Now, this is actually something that in the randomized clinical trial, and they published the result, made the beneficial of this system not existing. So, and basically we actually end up understanding that could be an alert fatigue, or it could be a not trust in the system, maybe for lack of communication. So we went through and understood that there was a training being made by the doctors that they introduced this system. But ultimately, there's an interesting thing that you have now a system in between that might or might not agree with the dispatcher. And this is really one of the big challenges that you have in general when somebody has to make a decision. You can ask the system a second opinion. So normally if you have two experts and me and John do not agree on something, we can at least have a conversation and say, John, why don't you agree? And this is my point. First of all, you have no time to do it. And second, the system is not answering to you. So this is really an ethical issue. So I think the person who asked the question identified clearly a big area of concern.
Okay. And so now we have a question from Christian coming in. He asked, so if the dispatchers were trained on the AI system, and how did this happen?
That was part of our, let's say, assessment. So, and since we did the assessment together with the key stakeholders, so we have to ask how the dispatcher were trained. And basically, the dispatcher were trained with the workshop made by, let's say, the key stakeholder that managed the project. But now in the second phase of the project, we would like to understand better how the communication was made, how the explanation of the output was given. Because if you are having an AI system blinking, then you only have two possibilities. Either the blinking is happening before the dispatcher has made his decision, or the dispatcher has already made his decision, or it might happen at the same time. If they do not agree this action, there is a very ethical issue, and there is not a possibility to explain to the dispatcher why the system believes, well, it is only a probability, why the system is blinking. And this is really a major ethical issue that is left open to them to solve in our recommendation.
Okay, yeah. Now something maybe the use case is more from my own interest. It really goes into sort of the sort of like, how do you assess ethicality of a sort of an AI or an algorithm? And because it's often, you know, these principles that are given and that we base our decisions on. I mean, so many of, as you said, that are pulled from the bioethics, and original bioethics, for example, they are sort of insisting within an equilibrium and coordinates. I mean, how do you best measure this? I mean, because obviously sort of the autonomy only goes to a certain way, and then the sort of like this is like there's natural limitations, because at some point, I mean, if you think about other basic laws, I mean, your freedom ends where somebody invases somebody else's. So how in the measuring of or assessing the sort of ethical principles do you take into account the different levels of principles?
Well, that's a very important question. So the way we handle it, first of all, we have no solution. So we have
yes, this is obviously it's a
but what we do is we actually use collective intelligence. So we bring an unexpected large group of experts. Some of them are experts in ethics, so philosopher, not necessarily in healthcare. Some are experts in healthcare and ethics, so specific. Some are experts in technology parts, so machine learning engineers. Some are actually experts in law or law and healthcare, because they're very specific as well. And we have chosen the framework of the Trustworthy AI to leave at least have some metrics. Now, within this framework, when you start having to measure things like fairness, for example, or well-being, or all kinds of things like human agency and oversight, you can only give an opinion. So, and by having a discussion between different angles and different experts with different angles, you could arrive to at least a collective intelligence and give our best interpretation. Of course, we might lose parts, but I think by forcing people to go to the framework, you get into a very practical way of saying, okay, what does it mean fairness in this case? What does it mean, for example, is that legal? Is accountability respected? And obviously, certain elements of the framework are easier to measure and others are extremely difficult to measure, But in reality, what we are trying to do, and that's also part of the strategy of the EU with this law regulation, we're trying to minimize risk. So this is all about risk, and risk is really risk harming people. So anything that is in that area has a high priority. But yeah, we publish the results, so I'll be very happy if somebody has comments, and also you, of course, because we publish as the best practices because there are very few cases of real example with systems that are deployed. So this is not a toy system. This is actually an AI system that are being, we talked exactly recently, and we will continue with this case. In the meanwhile, notwithstanding our, let's say, recommendation, they deploy this system in the entire region of Denmark. So if you call 112 in Denmark, now you have this system listening. I cannot hear you. You're muted.
You already answered the second question coming in. That was really about the principle of fairness and how can you, because there's very different interpretations, but obviously if you get sort of like different opinions, obviously you will get sort of like different interpretation also of the level of fairness.
On fairness, I would like to say something because we spend quite a bit of work in other cases. So fairness is like a layer thing, because you have fairness at philosophy level, then you have fairness at the application level, like in healthcare, and then you have fairness that you can measure in machine learning. And in machine learning, you have numbers. In healthcare, you have a meaning of what kind of fairness, and there are also tension because you cannot have them all. So if you have one criteria for fairness, you might exclude another one. So it's very important that in the framework of the EU, it simply says should be fair, right? Yes. But what is fair? Fair is always connected to the domain, and it should be an agreement within the key stakeholder that this is a reasonable definition that makes sense. Otherwise, then you can have all kinds of different fairness criteria, and then the engineer will always find a number.
Yes, indeed. This is the assessment is difficult. Okay, very good. Thank you so much for giving this today and also for the interesting discussion. Especially enjoyed the last 2 minutes on the ethics view and the definitions. So great to have you here and looking forward to connect with you. And also the Brella platform is everybody can reach out to you and ask you questions about your work. And also you can see the link here to interact with it. So
thank you for inviting me, and thank you for people listening to the talk.
yes.